Okay, we are Team Philo, and we are a team members from Cal Poly San Luis Obispo. We are presenting about the Cast and Steel 2024 competition and our designed Halligan bar. The team members include Michael, Riley, Vincent, and Will. Initially, we completed a series of into the Halligan bar's origins, and from there we began doing 3D modeling in SolidWorks, and below we are going to go through some of our design drafts. Seen here in design draft 1, we initially started with an I-beam style bar, and with this bar, it proved to be too cumbersome to hold after conducting more research, so we decided to pivot and move towards a more traditional bar. This more traditional bar can be seen here in design draft 2. This is more similar to the original Halligan, but unfortunately it had a few problems. A couple of things of note were it was a little bit too heavy, and it was missing around the sharp edges. So when we performed FEA analysis, we realized that this would cause stress concentrations. So as such, we refined the design and moved to design draft 3. Presented 3, we can see that we've added more fillets and eased the edges around the sharp corners. Furthermore, we have added knurling through the form of helical cuts on the octagonal bar shape. And presented in design draft 4 is ultimately what our final design ended up being. With this design, what we liked about this is that it adheres more towards a traditional Halligan bar with its circular shape. The circular shape makes it a lot easier for users to grip. And as well as this, we also added a helical cut to serve as a form of knurling that was directly cast in the part. These helical cuts also serve an aesthetic purpose, and we believe that these make the Halligan bar look particularly beautiful and improves upon not just the function, but the form as well. Next, we moved into our gating design.
So our first image shown here is the gating design that is kind of compacted as for a better view. It's just a simple gravity-fed gating design that will feed into the runner system, which will then feed into the Halligan bar via the screws. The riser system, which is the long side, will improve the porosity inside of the finalized cast, because as metal increases inside of the structure, it will begin to fill and solidify inside of the mold, and the more liquid you fill into the gating system for overflowing pouring cup, the more liquid you can fill into the mold cavity. These functions, as well as these functions, help feed into the finalized simulation after a couple of iterations. The next slide that we have will show the gating simulation in SolidCast. It is a 3D mesh program that shows how molten metal will flow into the system within a gating system using STL files. Should improve the final picture.
The final picture shows our ultimate gating simulation results. These include how long it took for the total fill to take place, the maximum casting temperature and the minimum casting temperatures. And the most important thing to note from this slide is that we had a 100% fill rate, which was the most important thing for us moving forward with this casting gating simulation.
This is our final design of our halogen bar, and it ended up being 32.23 inches in length and about 9.4 pounds for how much it weighed. And the post-processing results, the fork and the pike actually ended up coming out pretty sharp just from the mold itself, which was somewhat unexpected, but welcome. So the ads was really all that we had to post-process, and that just consists of using an angle grinder and a file and some sandpaper at the end to get a nice sharp axe point on the end of that ads. And here's a video of prying some wood with the ads. Oh, he's going in there. Oh, look at that. Yeah, beautiful. Then the next video, we'll be testing the pike. This is breaking down a door, fireman style. Bang! Look at that. Breaks down the door like butter.